Hello, this is Andy Frassetto with the Incorporated Research Institutions for Seismology, also known as IRIS. This presentation is an overview of the new National Science Foundation sponsored resources for doing geoscience with portable magnetotelluric instruments. I want to start by thanking all my co-authors, but especially David Goldak and Maeva Pourpoint at the PASSCAL Instrument Center at the New Mexico Institute of Mining and Technology, and Justin Sweet at IRIS, who are all playing major roles in this work. PASSCAL stands for Portable Array Seismic Studies of the Continental Lithosphere, and the PASSCAL Instrument Center, or PIC for short, has long supported principal investigators who deploys portable seismographs to study many different facets of the Earth system. The team at the PIC has facilitated more than 1,200 experiments across the world over the last 24 years. PASSCAL is part of the Seismological Facilities for the Advancement of Geosciences, also known as SAGE, that IRIS operates on behalf of the National Science Foundation. This presentation focuses on one of the new activities supported through SAGE, adding magnetotelluric, or MT, instruments to the PICS pool and developing customized resources and support services for the PIs who use them. The PASSCAL MT instrument pool is small but growing. It includes 13 new long-period LEMI 424 MT systems, which are low power and operate an easy to deploy 3-component fluxgate magnetometer. We have also begun to procure complete wideband MT systems as well, following a lengthy process of market research and instrument evaluation. The initial pool of wideband instruments includes 6 Phoenix MTU 5Cs and both Phoenix and Zong induction coil magnetometers. The cross usage of instruments from different manufacturers is widespread in seismology, but uncommon in MT, and this has required extra engineering work and testing by the PIC to validate. We believe that this flexibility will provide the most versatile instrument pool for the SAGE PI community over the next decade. Although induction coil magnetometers for measuring horizontal fields will exceed 1 meter in length, we envision a model where the shorter length coils, MTC 180s and ANT 7s, can be more easily buried to obtain vertical field measurements. In general, users should be able to get reliable data up to at least 1 kilohertz, making these instruments a resource for shallow, high-resolution MT studies, in addition to crustal scale MT applications. We plan to procure at least 7 more complete wideband systems in 2022. Lastly, we have over 90 boron silver chloride electrodes for use with either mode of MT instrumentation and with limited restrictions due to their non-toxic chemistry. The PIC furnishes field laptops, which include acquisition and/or data processing software for in-field data validation during data acquisition. These field computers are SAGE facility property, but are loaned to PIs at least through the data acquisition phase of the experiment. The KMS 200 software is used for data viewing and processing of long-period MT recordings, and KMS is currently offering an extended license agreement for any groups that use the PIC LEMI 424 instruments. mPower is the versatile acquisition and data processing software package developed by Phoenix that is used for their wideband MT systems. Working with MT stakeholders, IRIS engaged in a multi-year process to identify gaps in data handling and processing resources, solicit community feedback, prioritize development goals, and hire a software developer to create new products for broad open access use. The first new resource is MTH5, which is a set of tools that support an authoritative new data and metadata standard in a hierarchical storage format for MT time series. This work has been led by Jared Peacock at the USGS with support from the SAGE Award and the USGS Community for Data Integration. Using the MTH5 toolkit, you can pull MT data from the IRIS archive and write it to a format structured intuitively for MT and exchange it with colleagues. In addition, data from a growing set of common MT instruments can also be read directly into MTH5. A publication describing MTH5 is currently in review with Computers and Geosciences. In addition, IRIS engaged with many of the same stakeholders to refactor the EMTF codes for MT transfer function processing, originally written in Fortran and MATLAB by Gary Egbert at Oregon State University. This occurred in parallel to developing MTH5 and leverages the new format. The EMTF codebase has been completely rewritten in a modular structure using Python, providing a recognizable and convenient framework for community users to expand upon or update. Under the new name AURORA, It is intended to serve as a long-term open source resource for MT data processing and is designed to work seamlessly with MTH5 formatted datasets. We are on track to release a full version of MTH5 and a beta version of AURORA in early 2022. I would like to especially thank Carl Kappler and several members of the SIMPEG community who we contracted to develop the new software and models for future community engagement with both AURORA and MTH5. Lastly, as part of its role in assisting PIs to steward their data, the PIC has developed specialty software for collecting and writing time series data and metadata into the IRIS archive-ready formats, such as Miniseed and Station XML. The PIC is also working with Phoenix to develop specialty internal use software tools to support the PIC's Zong coil calibration response format in mPower and to batch configure MTU5C receivers during routine testing and pre-experiment preparation. These resources will streamline PIC operations and ensure robust testing and throughput of both instruments and data sets. As PASSCAL MT has coalesced, we have worked to maintain connections with the community user base despite the challenges presented by the COVID-19 pandemic. In mid-August, this included a 2-hour-long mini course during the virtual SAGE Engage Facilities workshop. This was organized by SAGE facility staff and members of the USMT community and served as a comprehensive and interactive introduction to the PASSCAL MT resources and the scientific opportunities presented by MT. We also conducted a short survey to gauge current user needs and the potential usage cases that we may see in the future to hone our approach going forward. The survey elicited a range of useful feedback on several fronts, and I've included a few brief examples here. For instance, a significant number of respondents expressed interest in using MT instruments for teaching and coursework. This is a common use of some instruments at the PIC, such as multi-channel seismic systems, but is not something we had originally considered when envisioning the MT pool. As such, we will ensure that our training includes these possible scenarios. In addition, there continues to be considerable interest from PIs in proposing mixed mode experiments, in which both seismic and MT instruments are deployed throughout the same field campaign. Again, this reinforces how the PIC will develop guidance and training for PIs and practices for experiment preparation and logistics. Other feedback helps us to prioritize our future engineering efforts. The survey demonstrated uncertainty on whether PIs would need support for extended duration deployments beyond a few weeks, particularly for wideband instruments. This is a topic that we will continue to investigate and revisit with our user base to ensure that the power systems for our stations are appropriately configured. Finally, a majority of potential users expressed a novice understanding of MT data formats and data processing, which further emphasizes the need to create and promote resources that allow new users to be confident in collecting MT data and transforming these into robust research products. On this note, we plan to hold an in-person training course for MT instrumentation and data processing in early summer 2022. This will be organized similarly to the successful US Array seismic data management and processing short courses that IRIS ran for years during the height of EarthScope. The goals will be to prime a new user base consisting of both seismologists curious about MT and established EM or MT science users wanting to understand the resources assembled under SAGE. We have funds available to support at least a dozen course participants as well as several instructors. Applications will open early next year, and in particular, we would like to support a diverse cohort of attendees and especially early career scientists. We expect to finalize the dates of the course in January and an agenda soon after, but we envision a 5-day program either in late May or early June. The program will include an introduction to EM and MT theory and highlight science applications of modern MT instruments. However, the majority of the course will immerse attendees in using the instruments and driving the software resources to format, process, and invert MT datasets to begin to characterize Earth structure and properties at depth. The PASSCAL MT activity and other core facility programs make use of a robust community governance process that IRIS has utilized for decades. An advisory committee and 2 working groups have been instrumental, pun intended, in providing regular feedback as these new capabilities have been built from scratch. You can see the current membership of the EMAC, the Electromagnetic Advisory Committee, that brings together facility staff and faculty and researchers from the scientific community. The EMAC reports to the PASSCAL Standing Committee, which is a larger group that oversees all portable instrument programs under SAGE and includes an MT community representative and the EMAC chair. In summary, this newly established resource for MT practitioners provides a modern set of instruments which are available to all, but are prioritized for US-based academic investigators. The PIC also provides equipment training and experiment support services tailored to specific PI needs, software resources to handle and archive data processing software for both in-field and longer-term usage, and specialty training opportunities and resources, all overseen by a robust community-led governance. As a whole, the PASSCAL MT facility is envisioned as a community resource that provides a level of support for MTPIs that the seismology community, supported through the PIC, has benefited from for decades. To conclude, I hope this presentation has provided a useful overview of the PASSCAL MT facility and what it can potentially offer to your science. These instruments are available now, and the demand that we see in the coming months, particularly from US investigators, is likely to influence the level of continued investment in MT by NSF through the remainder of the SAGE award. Future updates on the program will be available through the MT mailing list displayed here, as well as the IRIS homepage. Please contact me if you have any questions about the program at andy.frassetto@iris.edu. I will close with acknowledgements to the many other people at the PIC, IRIS, and in the MT science community who have greatly aided getting this effort to where it is today. Thank you all very, very much.